Hi everyone, so this is Psychology of HCI Part 2. Last time we covered some aspects of cognition, sensation, perception, and memory. And this time we'll wrap up that discussion with some conversations about vision and how certain design principles or concepts. Starting with vision. So this is important I want you all to just kind of stop on this for a second and think about this, on how important visual design is. Now, I said in this course, we're not getting into visual design, graphic design, user interface, any of those kind of things. But that does not mean they're not absolutely critical. So when we look at visual processing, about half of our brain is involved in visual processing. 70% of all of our sense receptors are in our eyes, and we can typically get a visual sense of a scene within a tenth of a second. Our visual processing is incredibly fast and incredibly focused in terms of how our cognition is kind of set up. So in our eyes, we have two items of interest. We have cones and we have rods. Your cones are your foveal vision. This is going to be your very precise, your higher definition, if you want to think of it that way. But it's a small space where your rods handle your peripheral vision, which obviously is a much bigger space. Cones is your color vision. Rods do not have color. And then it breaks down, as we have low light versus high light sensitivity, as well as how slow or fast they fire. And how they progress through the brain as that information gets kind of sent up. So looking at foveal versus peripheral vision, here in the center where we can see this lectern a little bit clearer than everything else, that is because of our the foveal vision is giving us a higher definition image there, and the peripheral vision is a bit blurry. And right here we've got this light gray spot here on the right a little. That's an example of our blind spot. So it's a transitional point between the two, and so something to be aware of. Most of the time we don't run into that stuff in design, but it's an important construct to be aware of, because who knows what you may be called to design. So how does all this work in terms of visual sense information up to perception? So we're going to focus on Gestalt psychology. So the whole is different from the sum of its parts was kind of a catchphrase, if you will. So Gestalt psychology was an early 1900s Germanic school of thought. It's still actively used even in the clinical spaces. There is Gestalt therapy. For folks, it means basically a pattern or a configuration. Characteristics of visual processing have design implications, and they've been captured through some aspects of Gestalt principles. So these are two examples of some listings of Gestalt principles. If you're interested, if you just Google Gestalt principles and look at images, there's a million of these things, a million different instantiations of these. But the things you generally have to remember, right, is proximity, so elements which are close together seem to be a group. Closure, we ignore gaps. Similarity, again, things that are similar probably are in a group. We can use borders in digital design to communicate a group, like the common region here. Continuity, so things that are on the same curve or on the same vector, if you want to say that, are considered to be in a group. Figure and ground, so our brain instinctively recognizes if something is in the foreground or the background. Symmetry, our brains like order, we like symmetry typically. Things that are kind of out a little bit tend to bother us. And common fate, elements which move in the same direction seem to be a group. Here's another example. I really like this one as well. And then if you want, a lot of people have done this next one, or they take the word gestalt and make it examples of them. So um, that's something to kind of consider. Focus on these because your design processes will need to follow these. For example, if you put different things together and you don't, let's say they wouldn't generally be considered similar, but they are in proximity, and you start to have errors, let's say your users aren't using that correctly, okay, then you might want to make use of the common region tool where we can box them in a way to explicitly say, hey, these things are together. Sometimes you need to do that. It really just depends on what your use case is. Direct manipulation, so we talked about this in a previous video, but remember, we're hacking the physical world into the digital. So this goes back to the aspect of our learned behaviors in the digital space. We don't have the kind of fortune of all of our life's physical experience from being a baby all the way up to tell us how things should work. So direct manipulation was a quick way to get around that. It's important to note, right? This is purely an abstraction. You're not actually dragging, you're not actually physically moving a memory item from one place to another. Instead, there is a command that will run in the background to just move that within the overall architecture of your data or your storage. But again, we use this abstraction, and this principle is largely what made personal computing viable for most folks. Another one you'll run into a lot is skeuomorphic or flat design. So skeuomorphic, we kind of make it look like a physical world. We lean on existing physical mental models. It does have an increased base cognitive load because there's more stuff there. So good examples of this are the bottom left here. We've got the old school Kindle, first generation Fire here, where things look like they're on a book rail, even though they're obviously not on a book rail. But it kind of communicates, hey, these are things like books where you can interact just with them in this way. Similarly, early iOS, it needed to have a distinction between the icons and the background. So if you notice, a lot of these have a slight shading around them to create that pop-out effect. Now, flat design has become more popular in recent years, but it's a cleaner design. So we've got the old Windows 8 style menu here, as well as kind of more modern iOS designs. It's a cleaner design. You're relying way more heavily on digital mental models and associations than you are on physical. You have a decreased base cognitive load from the visual system, but the associations won't be as strong. So learning, you might have some issues there. And ultimately, user research and evaluation will determine which works best for your particular use. It isn't clear that skeuomorphic or flat are by definition better. So now we're going to look at Fitts law, two specific laws that we run into a lot in digital design. So Fitts law, simply the time it takes to navigate to an element is a function of the distance and the width of the element you're trying to navigate to. And there are calculations for this if necessary. What's important to remember, right, is this is a function of like missing items. So if somebody needs to quickly click a button, you might want to make that button quite large so that they don't miss it if there's a time constraint. The other thing is this second component. And this, if you reflect, you will notice this. Typically, critical actions or important things end up getting put in the corner of your screen. And why is that? Well, because according to Fitts law, corners are basically infinitely wide. It's kind of a weird counterintuitive thought, but you can't miss them. You could totally cover your eyes and they say, click the button that's in the upper right corner. You don't even have to look. You can get there no matter what. That's why our start menu is in the bottom left typically, and some other things will be up. Some Mac functions, for example, will be up on the top in the corners. That's why we do that. So, like I said, you're not likely to need to do the math, but you have it if you need to, depending on your use case. The next one that's relevant for us in digital design is the Hicks-Hyman law. So the more choices a user has increases the cognitive response time, and it follows the logarithmic curve. Most human performance things like this do follow a logarithmic curve. So this is a big consideration as we're designing navigation or hierarchy levels. This is also why it's critical to pay attention to your information architecture, so you're putting topics or concepts in the right order or hierarchy. This will help decrease the impact of the Hicks-Hyman law. What's important to note, though, is since it is logarithmic, most complicated systems are going to top out at the top of the curve. So it's not a huge focus, but it's still important to be aware of. We don't want our things to be extremely painful to use or slow, or you have to go through 15 windows to get where you're going. But yeah, with more complex systems, control rooms, aviation, those aspects, you will likely have to present a certain number of options that will make it at the maximum response time. So, and then Jacob's law. So we've talked about this a little bit with design inheritance. So Jacob Nielsen said users prefer website and apps that are similar to ones they've used before. This is based on this assumption that users spend the majority of their time on sites or apps that are not yours. So because of that, they will be, again, inheriting those mental models from all these other designs that exist out there. And if you're going to deviate, you need to have a good reason and some significant supports, training, feedback, those kind of things. We've talked about this a bunch and we're going to keep doing it, but ubiquitous computing means nearly all devices have an experience. So what does that mean? It means you need to evaluate other applications or things in the space. That doesn't mean there's no room for novelty. It just means that you need to do that work ahead of time. There is a potential increase in risks, and there's higher learnability when you are deviating. But again, the gains from your design might be significant enough that it doesn't matter. So now Nielsen's heuristics, these are a huge component of what we do as human factors or UX folks, where we're getting asked a lot of times to just parachute in and give an overview or an evaluation from our perspective of how this system is doing. And one of the most impactful and thorough tools you can use is Nielsen's heuristics. So there's 10 of them, but we're going to go through them one by one. But they're incredibly important and largely expected by users. So, all right, visibility of a system status. You need to communicate with your users what's going on. Match between the system and the real world. The design should communicate in a way that meets the expectation and uses languages familiar to the user. Like when Microsoft tried to get away from old crazy error messages to just give you a sad face and say, oops, something went wrong. User control and freedom. So exits from processes should be present and obvious to the user. Undo and exit functions are a key to giving a user a sense of control. It's also like cancel. Consistency and standards, so users shouldn't have to wonder if different words, actions, or situations mean different things. So remember Jacob's law. Error prevention. So well-written error messages are important, but removing error-prone situation is best. You need to iterate often and early to find actions that are not working well, either interactions. You'd refer to an interaction design text like about face or something to help guide that. But you will identify those from your users. Either they will tell you this doesn't work right, or you will notice that they're not being successful. And you want to capture that as best you can. Recognition over recall. So users should not have to remember things from one part of the interface to another. Again, in digital space, not doing this is really just laziness. There are some instances, I suppose, from a security point that you may want users to, you may not want your system to remember those things. And that's okay for some of those. But we all know systems that could be saving information and don't. So then flexibility and efficiency of use. This is one of our biggest hurdles in digital design. We have to try to capture as many users, user journeys, and goals as possible to make sure it works for as many folks as possible. Shortcuts, pins, and alternative pathing are critical. Again, this is everything comes back to user research, frequent and early. Aesthetic and minimal design. So this, you can go either way, right? You can disagree with this one a little. Interfaces should not have information that is not relevant or rarely needed. Well, what if you're trying to support users that have a lot of different needs? You know, you might need some cluttered interfaces are a little cluttered for a reason, and so that comes back to that, you know, always understand what you're fixing before you try to fix it and why it is that way. Help users with errors. We talked about this, you know, visual cues. This is a great one. When I fill out a form and I miss something and the form doesn't, like, 5-alarm fire highlight what I missed, I'm annoyed and frustrated because it's lazy. It's super simple to do that. Help and documentation. This is the other thing that, especially as your applications or your specific use case increase in complexity, you really have to document well and make sure that's available to the user in a way that's understandable. Stimulus response compatibility. So this is another one that we can run into in digital design. You know, the goal of the user should physically map to the action, even if it's a digital action. This is mainly right because if somebody says left, and then as you see here, you've got on the bottom here, you have left the word on the right, and the test would be you're supposed to hit the right button, but the word says left, and that's kind of, it creates an issue in our brains. It's incongruous. So another example would be like the Stroop test, where we're asking people to remember words like red, but they're in a blue font. Those kind of aspects. Norman's Gulf. So this is a big one in digital design. This is basically how do you facilitate the trial and error that your users are going to do. So it's basically a trial and error loop. I do a thing, what happened? Is that what I wanted to happen? Yes or no? Okay, if it's no, don't do that again. If it's yes, great, I found out how that works. You really have to be intentional about how you design this, and make sure that that loop is fairly, you know, there's not a lot of struggle in that. You know, your users are going to be able to flow through that loop without any kind of fatigue of using your product or any kind of cumbersome steps or anything like that. You want to make sure that that's as clean and smooth as possible. Now information visualization. We'll go into this in a little bit more detail later too, but just kind of the basics, right? We use information visualization to communicate data. This is leveraging our visual processing to understand what basically would be considered textual or auditory information. So we use charts, graphs, they tell a story, they can be simplistic and should be, you know, avoid 3D or flashy traits because they just add cognitive load, but they don't actually help your understanding typically. Avoid relative comparison if details are important. This is the curse of the pie chart. Try to never use a pie chart. That's kind of the one principle. You want to use a pie chart to show basically this. Hey, this light blue thing, that's big, and it's more than all of this. That means this should be our focus. If you show me a pie chart and then say, so let's talk about purple, teal, and orange, I'm going to throw it at you. typically you just avoid pie charts. There's better ways to do it. You want to take caution around novel applications of established models. Again, if somebody sees a bar chart, there's an expectation of what you're communicating. Don't get clever. New visualizations should rely on skeuomorphism or realistic design. So we see this with, like, for example, having your thermometer readout on your HCI being an actual thermometer shape. We do those things to reinforce whatever we're showing. But yeah, that's kind of the big details. This bar chart here at the bottom, right? It's 3D. Stop it. Unless that depth gives me data, like in a Z axis, I don't need this. All it does is add cognitive load and thinking. We just try to make it simpler. So now we're going to go through a few slides before we're done of bad design. And this is kind of my favorite aspect of any of these videos or courses, is to go through. Because I love bad design, because most of the time I can see exactly what they were going for, and it just didn't work out. And that's okay. That's fun. So here with the drawer, quick, open the drawer. But that handle is not, a handle should be for pulling. But that one is more a handle for carrying, per se, or moving the entire cabinet. So if you quick open that handle, you're just going to pull the whole thing over, which is just humorous in a slapstick way. And on the right, this would, I just am sad for whoever has to clean out the saxophone, I guess. Again, neat design. Let's put that up on the wall a little bit farther than, that's what I think. Here's some great ones. It's the Launch the Octopus. Credit to Doug Collins here for this. I grew up, my dad's an auto mechanic, and I still never knew what this symbol was until I had a truck and spent time trying to figure it out. This is how you illuminate your bed, but it's also how you launch the octopus. And then here, so this next slide will show what this is supposed to say, okay? And I want to capture this in a couple different ways. If you've never seen this before, take a second and try to see what this is supposed to say, all right? There you go. So the way this website worked is if you hovered up here on the top left on the turquoise part, it would pull the turquoise all the way through it. And because of a kind of a clever color theory, it would blur out the blue, in essence, and only the red, because of the contrast between the red and the blue, would rebolden. Now here's the crazy thing. Now that you've seen it, and you know what it says, you should be able to read this. And that's a good example of top-down information processing. Once you know what's there, you can essentially force your sense, information and perception to give you the right answer. That's something I wanted you all to see, because it's one of the more unique things. And again, I can see where the designer was going for. And I think it's a really unique way of handling color and contrast, but just didn't work. Here's an example of a great sign, right? We've all seen these where just things didn't work out. You had a word that wrapped when it wasn't supposed to wrap. So instead of looking at apprenticeships, they're looking at app, rent, ice, ships. And then for any video game players out there, this is the map for Fallout 4 is where I pulled this one from, I believe. And I don't care what anybody says, the map design in the Fallout games is an abomination, a crime against humanity, and they should be stopped. It's no good at all. I understand what they're going for. It's unusable and garbage. Here's a few more. So, this one's my favorite. I had this from renting a car recently, where the shifter is a knob positioned kind of closely to where the volume knob is. So I could see this being a concern. You're driving along and somebody tells you to turn down the music. You reach over and grab the knob to turn it down the way we've done in every car forever. And actually what you're doing is you're going to force your transmission to explode by moving it down to reverse or park suddenly, and you're going to have a real bad and expensive day. Um, I can't believe this was ever considered to be a good idea. This isn't exactly digital design, this is more of an industrial design thing, but still, shame. I gotta think also, 1 week of user testing with this thing would have captured that problem. And then, of course, my favorites. I always love when the labels, or companies try to save some money by just, okay, we're just going to use the same label template, and then we're just going to change what's on it. But then you accidentally grab your insect killer to spray down your cookie sheet. I always love these. There's another one that was, I believe it was Tylenol PM and a laxative that had very similar labels. I could be wrong on that, but I think it was those two. But you can find countless examples of this, and they're great. And again, I understand why they would think, oh, initially, well, yeah, just let's use the same template for all of our labels. That just makes sense. We'll redo the titles and all the warnings and everything. Like, well, what's the problem? And then you don't realize until you see them next to each other. So here's going to be some explicitly digital ones. So this one, most of us have seen this. I'm not really an Apple user except for an iPad, but I have gotten this, or my kids have while I'm helping them with stuff. And oh, you can't take a photo. You can manage your storage and settings. All right, well, let's hope that photo wasn't time sensitive, like a kid's first step or something. But the other problem here, right, is there's no clear, instruction here. What are they telling us to do? Go into settings? Where in settings? And then what do I do when I'm there? This is just one of those things. Apple is I know some people get real antsy about Apple's strength as a design organization, but no thanks. I'd say when Apple does do neat designs, they're really neat, but then we end up with 10 years of this garbage. So it can go both ways. Had a little hiccup. So here's an example. This also could be considered a dark pattern or dark UX, but if you're looking here on this, and keep in mind also, a lot of these I'm showing you are probably way out of date. I don't know if these interfaces still do this. But here we have a drop down for picking a country of residence within your travel insurance. But odd, they have the don't insure me, so like, hey, I don't want travel insurance, right between Denmark and Finland. Not sure those categories line up. So that is a great example of a dark pattern at worst, or just bad design at best, depending on what assumption you want to make. And whereas as an airline company, I feel fairly confident making the first one. So, and then here's these. You don't see these quite as much anymore, but I hate this. If all these web companies are going to make us all have applications, then I should never have to go to your website. Like, modern applications can handle any interaction that I need to do. And I'll be honest, I'll bet you good money that at the time, if you were to ask, I believe this image, I don't know if the current Hulu app does this, but if it does, I bet if we ask their designers, this is a save strategy. They make it harder to cancel by making you navigate to somewhere else. I would bet good money that that is what they're trying to do there. And I hate that. If you're going to make me have an app, then I should never have to go to your website ever again. I just shouldn't. I mean, especially you think about, some people might say, well, security, two-factor authentication, I can do two-factor authentication from an app. Also, if we're really being honest, these phone companies have more of our biometric data than most other things. So if my thumbprint isn't good enough for a two-factor authentication, I don't know what to tell you. And of course, the classic, right? Send versus send all. That's just bad design that they're right next to each other. Or reply to reply all. Just move them. I don't understand. I mean, now we've all had this experience, and we continue to have this experience. This is one of those where, well, I had to send something inappropriate to everybody on an email chain, so therefore all of the generations that came after us should have to. Which is sad. Criminal, really. All right, that concludes Psychology of HCI Part 2. Next, we'll start jumping into methods. Thanks.